Okay, in section 4.7 we are still dealing with proofs, but in these problems, oftentimes the triangles are going to be overlapping. Okay? Not a huge deal, but we've got to stop and really dissect the diagram in order to see exactly what's being shown for us, or exactly what we're being given, or exactly what they're asking us to prove, because it's not going to be as obvious as it was before when I had just two triangles sitting next to each other. Okay? So let's take a look at our first example here. All they want us to do is identify the common angle. Okay? So what I strongly suggest you do is anytime you're given a problem like this where the diagram overlaps each other, is to take your pencil or take a highlighter or take whatever it is you have handy and highlight what you're even talking about. Okay? So we are talking about triangle ACD. So go to the diagram, take your pencil, take your marker, take whatever, and start with point A and trace it to C, and then to D, and then of course finish the triangle by going back to A. So there's triangle ACD. Now, we are also then looking at triangle ECB. So again, do the same thing. Trace the triangle. We're starting with E, heading to point C, and then to B, and then back to E. So there's triangle ECB. So now that we have traced the two triangles we're talking about, now that we are definitely sure which ones we're working with, what is the common angle? What is shared between those two triangles? Say that again? There's no angle B that is shared between the two triangles. Because here's the thing, folks. If you're not seeing it right now, sometimes it helps not only to highlight, but then to pull the two triangles apart from each other. The gold triangle, triangle ACB, looks something like this by itself. ACD. And then we have the purple triangle. So we are going through and asking ourselves, what angles, and I know it's an angle because that's what they're asking us for, what's the common angle between these two triangles? I was going to say, some of you said B. Well, is angle B even an angle in this gold triangle? No. It's not a part of that triangle. In fact, point B has nothing to do with the gold triangle. Right? So, we are looking at that common angle being this angle, angle C. Angle C is congruent in both triangles because it's the same angle in the diagram. Okay? Questions? Well, let's do the same process on the next example. This time, though, we are looking for a common side. A common side. So, looking through here, we have triangle ABD. So, ABD. That's this triangle here. And the other triangle is triangle DCA. Triangle DCA. All right, so looking at those two triangles, do they have a common side? What do you think? AD. Yeah, line segment AD. Absolutely. Line segment AD. That is the side that both triangles have in common. Okay? So please take a look at the third example. I would like you guys to work this one on your own. Now, the diagram is exactly the same as the previous one, but we are talking about different triangles. So please pay close attention to that. Okay, so looking at triangle ABD, and triangle BAC, what's our common side?
AB.
Line segment AB. Absolutely. Please make sure that you're marking it as a line segment. You got to put the bar across the top. If you're not doing that, I'm taking points off, folks. We are almost a whole semester into geometry. We need to be labeling things properly at this point. Okay? I am taking points off for things not being labeled properly. Okay, so we've identified that. All right, so why is this helpful for us? Well, we are going to be doing proofs. We're going to be doing proofs, and in these proofs, our triangles that we're now trying to prove are overlapping each other. So we've got to be able to dissect the diagram to see what the heck is going on. Okay? So, for example here, in this problem, we have angle ZXW is congruent to angle YWX. All right, well, let's see here. Whenever I'm trying to figure this out, it's always helpful to trace what they're talking about. They're talking about an angle, not a triangle, so don't make a triangle here, but trace the angle. ZXW, so ZXW. You don't necessarily have to trace it actually, you just need to take your finger or take your pencil and just kind of go along and find out which angle they're discussing. And so then we want to, I'll erase that, mark this guy. That little angle is the one they're talking about. Okay? So there's angle ZXW. That is congruent to angle YWX. And so starting at YWX. YWX. So that is this angle down here. So those two angles are congruent. All right, they're also saying that angle ZWX, let's look at that one here. So ZWX, so that's this angle, is congruent to angle YXW. YXW. This angle right here. So that's what's given to us. They want us to prove that line segment ZW is congruent to line segment YX. That's what they're asking us to prove. So, in order to do that, we have to try to find out what triangles are going to help us do that. Okay? So, first off, if we're trying to show that line segment ZW is congruent to line segment YX, the triangles we choose better have those involved. Okay? So, if I'm doing that, I'm looking here saying, all right, well, maybe this little triangle is what I'm going to be working with. Well, what do you think? Does that involve the givens that were? No. So maybe I don't want to choose that triangle right away. That might end up being it, but let's see if we can find something else. I see this big triangle here involves my angles. Now maybe you don't see that. Maybe it's confusing to you what's going on, so let's go ahead and redraw those triangles. Like I did in that very first example, I pulled the triangles apart so that we could see it easier. So off to the side somewhere, maybe you want to just do a sketch of your two triangles there. Now, how did I know to use those two triangles? Well, because this is line segment ZW. I need that. And I'm given that angle ZWX is congruent to another angle. And I'm given that angle ZXW is congruent to another angle. So I'm given lots of information about this triangle, and that side ZW is the one I'm trying to prove is congruent to another one. So I know, hey, I want to use triangle ZWX. Well, that has a counterpart. Triangle YXW. And again, we know that we're trying to prove line segment YX is congruent to line segment ZW. We are given that angle YWX is congruent to another angle. We are given that angle YXW is congruent to another angle. Okay, so now that I have those two triangles pulled apart from each other, what's the next piece of information we're going to need in order to show the triangles are congruent? And by the way, why am I wanting to show triangles are congruent? Any ideas?
So that you can have, so that you can find the sides.
Right, and I'm going to be able to do that because we know that corresponding parts of congruent triangles are congruent, right? So in order to say that, I've got to have congruent triangles. Okay? Well, then what's the extra piece of information I'm going to need here? Do I need another angle? Yeah, I need a side. Our 5 pieces of information that we need, our 5 shortcuts we can use, are side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse, leg. We have 5 shortcuts for triangles that we can use. Okay? Questions? Or you know what we're going to use? What are we going to use? Yeah, line segment WX is the same line segment in both triangles. So that means this guy is congruent to that guy. Okay? So yes, we're going to be able to show the two triangles are congruent. And once we have that, we can then show the parts we're trying to show are congruent are then congruent. Okay, good. So we've got all of our information here. We just need to put it together as a proof. And one thing I want to tell you in this section, we're not always going to want to use flow proofs. This proof actually is not that bad to do as a flow proof. Okay, it's fairly straightforward. In fact, we've done flow proofs that are as complex as this one before. Okay, but I guarantee you're not always going to want to do a flow proof. So because of that, I'm going to write this one as a 2-column proof just to remind everybody what a 2-column proof looks like. Okay, so we need to have 2 columns. That's why it's called that. One is for statements. One is for reasons. And our first statement should be our givens. So we are given that angle ZXW is congruent to angle YWX. And we're given that angle ZWX is congruent to angle YXW. Okay, well, we needed another piece of information. Those gave us our angles, right? Those gave us our pair of angles that we know are congruent. What was the other piece of information we needed? Or that we found out from the diagram? Our side, which was... Okay, make sure you mark it as a line segment, right? Line segment WX is congruent to line segment WX, and that's by what property? The reflexive property. All right, well, did we have enough information then to show our triangles are congruent? Yeah? Okay, so what are we going to call our triangles? Okay, so ZWX, we now have locked into stone what we have to name the other triangle, right? So triangle ZWX is then congruent to what? YXW. Triangle YXW. And that is because of angle, side, angle. Cool. Then, we're now able to say what? There it is. Line segment ZW is congruent to line segment YX because corresponding parts of congruent triangles are congruent. Very good. On the back side of your notes, I would like to work this proof. It's one in the upper right corner of your notes. Okay. This proof is actually a bit more complex than what we've seen in a while. Maybe what we've seen ever. Okay? So to look at this, we're given that line segment PS is congruent to line segment RS. That's easily marked. We see that. We're given that line segment, angle PSQ is congruent to angle RSQ. And again, that's easily marked. So we don't have to redraw stuff to figure that out. But we are trying to prove that triangle QPT, again, it's very important that you trace these things out so you know exactly what you're talking about. Oops. Triangle QPT is congruent to triangle QRT. Okay? Those two triangles are the ones we're trying to show are congruent. So that means we need to find side, 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 or side, angle, side, or angle, side, angle, or angle, angle, side, or hypotenuse, leg for those two triangles. The problem is the two sets of givens that we have aren't part of those triangles. So we're going to have to do more. Okay? We're going to have to do more. So we need to somehow use those givens. Now, obviously, the two givens we have aren't involved in the gold or purple triangle, but they are involved in triangles, right? Well, let's say that they're involved in, well, which one? Let's think through it here. What do you think we might need? Anyone? See two triangles that our givens are part of? Got to say it louder than that so I can hear you. QPS. All right, so if we look at QPS, if we're just looking at that, I see we have a side, we have an angle, and then QPS has a counterpart, right, of over here, QSR. Great. They share a side, right? We have congruent angles already. We have congruent sides already. We could actually show that those are congruent. Wonderful. If we did that, what is then the new information that we could pull from that to help us with our gold and purple triangles? I'm hoping everybody already sees that in the gold and purple triangles, we know that QT is congruent to itself. What else would we be able to say? Once we know the big triangles are congruent to each other, now what else could we say? PQ and QR are congruent. Excellent. Is there anything else we'd be able to say? What, Sarah?
Did you say that QS bisects P angle PSR?
It probably does, and I know it actually does, but that doesn't help us directly. The product of that, what else happens? What else is true? If it bisects, then what else is true? Why do we care that it bisects it? Because what angles then are congruent? Wiley? Jackson?
Could you say QT is congruent to QT?
Nope.
Is it reflexive?
Nope. Point T is not, or QT, well, QT, yeah, QT we can. I thought you said PT.
No, I said QT.
QT you can't, yeah, we already said that because of the reflexive property. We know that already, but we're talking about those angles yet. Sarah had an idea about that being an angle bisector. We don't care that it's an angle bisector because we already know that what?
Did they say that PTQ and RTQ are
Wrong angles. All right, we're going to be able to get there. Let me highlight some. I think it's going to help. I think some of you got it.
Yeah, wouldn't it be PQT?
Yes. Angle PQT and angle RQT are the ones we're looking at because, let me highlight our two triangles here. We are talking about this triangle trying to kind of be able to see the other colors here. That's why I'm not tracing it very well. Those two triangles we're saying are going to be congruent. Because we can say that. Off to the side, I'm going to kind of do a plan for our proof. So I'm going to say we need line segment QS congruent to line segment QS, right? Therefore, we're saying our two triangles are congruent. And how are we going to name the first one?
The first large triangle.
Yep, first large triangle.
QPS.
Okay, QPS is congruent to triangle.
QRS.
Okay, QPS, then QRS. I 100% agree. QRS. All right. And that is going to be by what?
Side angle side.
Right. Because we knew QS, right? And the other two givens allow us to say that. Good. Once we have that, we now need to talk about congruent corresponding parts. Right? Congruent corresponding parts. You guys have told me that we now know that line segment PQ would be congruent to line segment QR. Right? Because they're congruent corresponding parts. But what else helps us in the gold and purple triangles? Which angles now? PQT. Now, is PQT, T is not a point in our blue and red triangles, but it is a point in the two triangles we're using. So I would actually use T to name it, not S. But please remember that angle PQS is the same angle as angle PQT. From way back, Unit 1, almost day 1 of class, it's probably week 1 probably, we talked about naming angles. And this angle, PQT, is the exact same angle as angle PQS. There is no difference in naming them that. Right? Okay. So we are able to say that angle PQT is congruent to what other angle? RQT. Once we had that, Jackson, you then also said that what has to be true?
QT is congruent to QT.
Great. When we have that, we're now able to say our two triangles are congruent using what? Side angle side. Okay? Now that we have a plan for our proof, we want to actually write our proof. This proof is going to be far too complex to do it as a flow chart. So we're definitely going to want to use a 2-column format for this. So we need statements and reasons. And our first statement is our givens. So we are given that line segment PS is congruent to line segment RS, and we're given that angle PSQ is congruent to angle RSQ. Angle PSQ is congruent to angle RSQ. All right, so there's our givens. Next, going through our plan that we have, what else did we need? Or maybe we didn't get that far. Oh, we did get that far. What was our first thing we said?
The two large triangles.
Okay, so we want the two large triangles to be congruent. So what is the missing piece for that? Line segment QS. Right? So statement number 2 is that line segment QS is congruent to line segment QS. And how do I know that? That is the reflexive property. Excellent. Okay, well now that I know that those two large triangles are congruent, the blue one and the red one, I need to actually say that. I haven't stated it yet, right? So what are we going to name the first triangle? The blue one. QPS. That's what we named it before. Might as well stick to it. Triangle QPS is congruent to triangle QRS. Okay, and why do we know that? Side angle side. So, we now know that those triangles are congruent. The important information that we needed from that was what? Line segment PQ is congruent to line segment QR. And again, notice folks, we're just moving right through our plan. Right? That's why we do the plan. It makes writing the proof real easy. Okay? And we know that because of corresponding parts of congruent triangles are congruent. In that same step, I'm going to write this our congruent angles as well, because that was the other piece we needed, right? We needed to know that angle PQT was congruent to angle RQT. Okay, so that's all statement 4. Well, then we needed some more information. What's our statement 5? And that is because of the reflexive property. Cool. And so now we have statement 6, which we are now talking about triangle QPT is congruent to triangle QRT. Why? Because of side, angle, side. Awesome. So there we go. Questions on this proof? Now, I do want to let you know that the previous class, we did the exact same proof in class. It took us 7 steps because we showed different triangles. We didn't use the big triangles. We used the 2 small triangles here. Triangle PTS and triangle RTS. That will also work. It took us an extra step though. Okay, so there are oftentimes more than one way to do a proof. Just keep that in mind. Okay?